Yeah, so hello everyone. My name is Sai. So I'll be introducing myself and then I'm going to talk about the Gemini and GPT-4, and I'm going to break down exactly what all those results mean. And there were all these headlines and stats and stuff that Gemini threw, and some of them were kind of deceptive. So I'll be breaking down some of that, and then I'll be telling you about different ways that people evaluate LLMs. And then finally, I'll tell you like what are the most important benchmarks you should be looking at when a new paper comes out. So about me, I recently graduated with a master's in AI. I've published two papers in ML as first author. I've also done quite a lot of work in computer vision. I have a paper under review where I work with object detection and also generative AI. So with like diffusion models and generative image models. I've also worked as an ML engineer and data analyst, and I'm just really interested with all things AI ML, and I love keeping up with AI ML. Yeah, I was just looking at the chat. Just trying to minimize all the screens here. Um, okay, so the thing about Gemini and GPT-4, so this is not an apples to apples comparison. So they have like so many asterisks and brackets around. So I'll be diving into all of these before, but I wanted to highlight like why you would want to be knowledgeable about all these things about understanding the metrics deeply. So when you look at Gemini, this is like from their front line that on if you look at Gemini from on their webpage, like this is like the first thing that you see. And so they say that Gemini gets a 90% score on this benchmark called MMLU, and they use a technique called COT at 32. And then you have GPT-4 that they use a different technique. And then at the bottom, they say like, oh, this is like different evaluation techniques. And they just like put that in a asterisk. And then you would think that Gemini is just straight up better than GPT-4. But then we actually start digging into the technical report and um, looking at exactly how they compared it, what exactly is this COT at 32 and what is 5-shot, and how do we actually interact with it, which is pretty different from how these are being evaluated on these benchmarks. Um, so yeah, so they're really different techniques. And so does Gemini beat GPT-4? Sort of. So I'll be in this talk, I will be diving deeper into exactly what all of these things mean. But from now, you can see that this is from their technical report, and COT at 32 and 5-shot are very different. So over here, what they're saying is that using chain of thought at 32, they're getting 90%. And they compare it to GPT-4, which gets 86-ish% using 5-shot. But then when they do an apples to apples comparison here, the Gemini is actually worse. And on their new benchmark technique that they created, they say that it's better, which is like kind of misleading and not something you would know unless you actually read into the technical report. So there's this benchmark called MMLU. So it stands for Massive Multitask Language Understanding. And this is one of the most important benchmarks when it comes to LLMs. So it helps you analyze like how well they understand language, and it also helps us understand like how well they understand things like reasoning, language, and just generally understanding the world. And so this data set consists of 57 different tasks. So there's like math, history, law, science. There's also like computer science. There's psychology, biology. It's like a host of things. And so looking into the specific data set, there are 57 tasks in total. And the questions in the data set were collected by graduate and undergraduate students. And the important thing to note here is that it's collected like from online sources. And I'll be diving deeper into this later, but because they're collected online, like they're not 100% accurate, they're only as accurate as the quizzes and tests that are available online, and there are mistakes and scraping errors and all of that when you collect things online. And so in this data set is also things like the GRE and license exams and all of that. And it's also at a variety of different difficulty levels. So there's like elementary, college, professional, and high school level things. So it data set consists of a range of different uh, levels of questions. And so there's about 16,000 questions, and then there's about 5 of few shot. And this will be covered in the next slide, but know that there are 16,000 questions, and each of the 57 things has at least 100 examples. And one of the most important things that I think Gemini was trying to say is that they beat human experts at this data set. So how exactly they get it is that they use something called MTurk, Amazon Mechanical Turk, and that's like AWS's suite of things where you can get stuff like data annotation or segmenting, anything that needs data labeling or annotation. AWS has like the thing for that. And so they use this thing to get people to take this exam. And so they find that on average, people get 34.5, but then when looking at the 95th percentile, they get this 89.8% metric. And so just to show like what exactly this data set looks like, so I picked an example of computer science, and there's like a bunch of questions. I think these are kind of difficult. Um, so there's one that's about clustering, which is like a machine learning thing. Um, I quite honestly don't know any of these, um, but it's generally like college level computer science questions. Um, So how are LLMs evaluated? So there's 4 different techniques. The simplest one is zero shot. And this is how we interact with LLMs. So you ask a question and then you get a response. So in the case of the LLMs here, um, it's given a question like, what is the whatever? And then there's 4 choices. And then it asks the LLM, like, what is the correct answer? And this is fairly straightforward. Um, So the second option is few shot at K. So this is what is the thing originally where they compared GPT-4, and 5 shot at K is sort of the standard for how people evaluate LLMs or things in general. And so what few shot is that you're giving a couple example questions and then you ask the question. So here it says like, the following are multiple choice questions with answers about anatomy. And then it's giving the model a few examples. And so the benefit of this is first, the model has like a few examples of what is supposed to be there. And so that helps it give better answers. Second, it also teaches the model exactly how to answer. So it's more likely to answer with something that's like A, B, C, or D instead of just starting to explain the answer. So what we expect is just one token which says, is it A, B, C, or D? So this is few shotted case. And then the next one is chain of thought. So chain of thought is trying to get the LLM to reason. And so you would say something like, let's think step by step to the prompt. And what this does is, instead of just coming up with one answer straight away, it's going to reason first. It's going to think about what could be the possible options, articulate it, and then come to a conclusion. And through experiments, people find that chain of thought helps the LLM get a better answer because it's able to think before it comes up with a solution. And then the self-consistency, also known as COT at K. So this is what people mean, or when you read LLM reports and they say COT at 32, this is what they're referring to. So here, what they do is they set temperature greater than 0. So temperature controls the randomness of LLMs. So if you have a temperature of exactly 0, that means it's going to output the exact same answer every single time. So what's done here is that you set it above zero, so you get a non-random answer each time. Then you get 32 different responses from the model. And each time it's going to be different. And it's going to select the most popular answer. So it's going to take the majority vote and um, get that as the answer after taking 32 different things. And through experiments, people find that this is also like better than just generally few shot. And so what exactly did Gemini do? So they did something called, um, I forget the exact name, but it's, um, I forget the exact name, but it's, yes, what they do is they do chain of thought 32 times, and then each time you get a different answer. That's the same. But how it's different is that they have a threshold mechanism where if it is greater than a certain threshold, so for example, if the most popular answer is D 60% of the time, and they have this threshold that they get, if it is yes, like if it's more than that threshold, you choose that. If not, then you set the temperature to zero and then just do it as a simple 5 shot again. And so this is what exactly Gemini did, and this is their own thing. So they created this new technique of evaluating bench LLMs, and they say that they beat GPT-4. So this is like a tweet that sort of summarizes the whole thing. Did Gemini beat GPT-4? Somewhat. So the specific benchmark that they beat GPT-4 on is chain of thought at 32 using their uncertainty routing, which is what they call this modified chain of thought. So on typical evals where they're doing 5 shot, where you give 5 examples to the LLM, it doesn't beat it. And even on the appendix, even just doing regular chain of thought at 32, it doesn't quite beat GPT-4. But then on the specific technique where you give 32 different responses, and then if it's above that threshold, then it does beat GPT-4. And no one uses LLMs this way. So this is kind of like a little misleading and a bit deceptive. So yeah, I mean, this thing here, it's this asterisk here is saying that with chain of thought at 32, the model produces 32 samples. And if there's a consensus, then it chooses that. So the other important thing is like reported versus API. So here, if you see, they use reported, and then on the other one, they use via API. And the reason that knowing this difference is important is because generally models tend to get better over time. So between the release of GPT-4, I think in March, which is the 0314 means March 14th. And between then and now, they've constantly been updating the models. And so generally, each time they update it, it tends to be a little better. And so if you're using the reported, that is what the score was when they originally released it. And so you have a model that's being released in December, but you're comparing it to a score that was done in March. And so that's in generative AI, that's like a huge difference. And so this picture here is from Hugging Face. So what they do is they have this thing called Chatbot Arena where they give 2 randomized responses to a question. And then they have people choose like which one is the better response. And so you can see here that the Turbo, which is the one that came the latest during the dev day, that scored slightly better. And then there's the March 14th, and then below that there is the June one. And so this distinction is subtle, but then it's also important to keep in mind. Um, and so another thing that I wanted to talk about is like how exactly do they get these responses? So the LLM can output anything. Like what if it doesn't output A, B, C, or D when you give it these questions? When you give it few shot, it is generally more likely to do something like that. but then at the end of the day, it is still probabilistic. And so the way that they resolve this is that when you prompt ChatGPT using the API, there is an option to get back the probability distribution. So following this like diagram here, you have the few shot prompt, you feed that to the large language model, then you get this output from OpenAI where it has like the vocabulary of the top 100 likely things it will predict and what is the probability that it's going to predict that token, or that token is the most likely thing after receiving this prompt. And so in this example here, you can see that zygote actually has a higher probability than A, B, C, or D. But what they do is they do filter it for specifically A, B, C, or D, and they compare it only with that. And so in this case, the model does get an extra point, even though the highest probability was zygote. I thought this was just an interesting thing to know, like how exactly do they collect these things, especially when LLMs can be stochastic. So I just wanted to quickly pause for any questions if anyone has any questions they want to ask. Gonna pause the recording. Um, so this is my like favorite part of the discussion. So the most important thing to remember when thinking about this benchmark is that it's not 100% accurate. There is a YouTube channel called AI Explained that I follow a lot. And so the guy who hosts that, his name is Philip, and he did a deep dive into MMLU. And what he did was he was manually grading some of the answers because he created this version of ChatGPT, well, not version, but like he tried to have the LLM reason before grading it. And so when doing that, it's hard to auto grade it because you can't just directly get a response from the model. You actually have to scan through what it says. And so in doing that, he was looking at some of the questions and the answers, and he found that a lot of the questions in the data set itself are wrong. So he says that about 2 to 3% of the questions are wrong. And as I mentioned earlier, it's because they were collected online. And so when he was trying to so he was trying to collect them. So the questions were collected online, and because they're collected online, there are errors. And so when you have like OpenAI and Gemini comparing LLMs to like 0.04 or 0.02, when there's like a 3% error in the data set, like you're not getting that much meaningful information when it's comparing to like a tenth of a decimal place. So some examples of like what the mistakes are. So this is like the actual MMLU data set that um, Philip from the YouTube channel pointed out as an inconsistency. So here there's a question, the Anglo-American model being considered the best model in light of the recession in the late 2000s. And then it's like choices 1, 2, 3, 1, 3, 4, 2, 3, 4, and 1, 2, 3, 4. But there's like no context as to what 1, 2, 3, and 4 are. And so there's like no way for the LLM to get this right because there's just not enough information. And so there's a bunch of errors where there's just like not enough context because they were collected online and there's missing context for the model. Then the other thing is there are some factual errors. So the data set contains answers where you might have like in MMLU, A is right, but then in actuality, B would be the right answer. So even if the model gets it, like guesses it actually correct, because the MMLU thinks that it's A, then the model isn't scored as A. And then I mentioned earlier about the 5-shot, right? So the 5-shot is a set of questions where there are these 5 questions you prepend to the LLM, and then you get a response. And so this is referred to as the dev set. And so in some of the 57 different topics there are, the dev set itself has some errors in them. So if the input that you're feeding to the model has a mistake, then the entire response is sort of questionable. And two other things that he says is like there's questions about model situations that are sort of ambiguous, and some questions have conflicting answers where depending upon the source you look at, you might have different answers. So as an example here where there's no clear answer, it's when an attitude is communicated, what does it become? An opinion, a belief, a behavior, a point of view. And that's just like vague, like there's no right way for an LLM to like just guess A, B, C, or D when you give this question. And another thing is, what is the biggest cause of death in children under 5? And so depending upon the source, you'll get different responses, and like which publication or which set of studies you look at, you will have uh, different responses. Um, so a question is, do these errors lead to hallucinations? Um, I guess you could say that they are hallucinations. Um, so hallucination is sort of a more nuanced topic, because what we mean by hallucination is an incorrect answer, but hallucinations are just what LLMs do, and we only consider them wrong, or we consider them hallucination when they are incorrect. I can lead you to like a better like source explaining what exactly hallucinations are, from Andrej Karpathy, who was like, I think, one of the top people at Tesla in its early days. And I think he's also like deeply in OpenAI. Um, but yes, so I think this would lead to errors or hallucinations, as we call them. Um, so some other benchmarks that I wanted to go over. So there's HumanEval. So this is a coding benchmark. And so when people talk about um, coding or its ability to write code, this is generally the data set you want to look at. So there's about 164 Python problems. And when you look at these results, you will have something called a pass at K. So what that means is that you generate K different solutions, and you check if at least one of them pass. And if at least one passes, then you mark it as correct. And so I manually went through this data set. You can get it on Hugging Face. And they're generally easy to medium problems. You can like write it under 20 lines of code. And there are some hard problems, but they mostly skew from easy to medium. Another one is called Hello Swag. So this evaluates like common sense reasoning. So a question is like, a woman is outside with a bucket and a dog. The dog is running around trying to avoid the bath. She gets the dog wet, then it runs away. So that's like, how well does the LLM actually understand the world? And so humans get 95% on common sense. Uh, Common sense is not common, as they say. And um, so this is Gemini's score. So GPT performs better than humans at common sense, and Gemini is it as good at common sense compared to GPT-4. Um, and then this is at the bottom you have Llama. So Llama is close to Gemini on this, 84, 85. Um, yeah, so I think this is an interesting benchmark to like follow. People don't talk about this a lot. Um, and then there's another one called Big Bench Hard. So what this is it's a subset of a data set called Big Bench. And so it contains 22 question groups that are a subset of the 200 categories that are there. And so on average, humans score 45, and on expert, it's 80. And so this is like purely reasoning based questions. So this is a category for like, I think, Boolean algebra, right? And so, I mean, this is like not easy for people and even LLMs. So this is actually evaluating its ability to problem solve and reason. And so over here, there's something called shuffling cups. And so it's like I think of it as like the cups where you put a ball under a cup and then you like move them around and then you're like, which cup is it under? And so this is sort of similar to that. And on this kind of benchmark, LLMs get like basically random. Um, so this is tracking shuffled objects. So that is the state of the art is 24, and then the random is 22. But then Gemini, this is from Gemini, and so it does get. Wait, no. So the one on the right is from the Big Bench Hard paper, and this is Gemini's overall score. And
can I ask a question, Sai? These different evaluation metrics, are they made up by Google or OpenAI, or are there third-party organizations who are doing all this? Like, I'm curious who's behind all of these.
I think they are just generally established by the scientific or academic community. I'm not sure. I think some of them are from Google. I think if you look at who creates this papers, I think some of them are from Google, but some of them are from like top research labs, and some of them are just like maybe open source or something like that. But that's
Okay.
that's a great question. Um, yeah, so my overall point on Big Bench Hard is that it tests LLM's ability to reason and plan. And reasoning and planning is becoming a huge thing. I think in 2024, we're going to start seeing LLMs actually like problem solve and reason. If you might have heard of DeepMind, they recently released a paper where they use an LLM to actually find new knowledge and solve a problem that was previously unsolved. So it's something called a capset problem, and they used an LLM to basically. It's sort of similar to prime numbers, like how you have like we have a largest known prime number. Sort of an analogy to what DeepMind did is they found a bigger prime number using an LLM, but on a problem called a capset problem. Um, so yeah, so reasoning and planning is a huge thing, and that's gonna become a bigger thing in 2024. Pretty much all of the top AGI labs, so that's Meta, OpenAI, Google, DeepMind, they're all working on some form of reasoning and planning. And so when you look at Gemini, it does do a lot better than what some previous state of the arts were. And yeah, so that's pretty much most of what I had. So in closing thoughts, everyone wants to game these benchmarks. There's a lot of merit and clout in being able to say that you perform the best, but that's not how we actually use these LLMs. So while they are good to get an understanding of how exactly they're evaluated and how you get them, but like you don't use them like a benchmark. And I found this tweet just by saying ChatGPT developed by OpenAI in the prompt, you can boost its performance in coding in Python by 6%. And so that just goes to show like how sensitive these LLMs are to the prompt and subtle things. You have like so many examples where they just add random sentences to the LLM, and for some reason it performs better. For example, if you tell the LLM it's December, it gives you shorter answers than when you tell it it's May. And so I'm pretty sure like OpenAI in the system prompt, they do inject the current date and time. And I think maybe location or other stuff. So there's a lot of things that affect LLM's performance including stuff like telling that it's created by ChatGPT. And there's a lot of nuances in the details where subtle grading differences make a huge difference. And the important thing is to focus on the big picture. So the three things that are important to pay attention to is when someone is able to decrease the size of a model while maintaining the accuracy. So the cool thing about mixed trial, and so I'm talking about mixed trial because I will be giving a talk on Jan 8th about the Mistral paper. What they were able to do is they're able to create chat GPTs performing models while being like much smaller than chat GPT. And even for their 7 billion parameter model, it performs as well as models that are twice as big. So this is a trend to watch. And so when someone builds a model that is much smaller but beats something that's much bigger, that's something you should focus on. The other thing is just generally generational improvements of 4 versus maybe 4.5 or 5. Small things where it's like monthly updates don't mean that much. And the important thing is that the data set is not 100%. So small differences, like less than 3%, are not that impactful. And so, as a closing thought, if this interests you, you can, and you want to learn more about this, you can DM me on Slack anytime. My handle is SaiB. And if you want to chat about it on LinkedIn, I'm always happy to chat more about it. I also do make daily posts on LinkedIn about ML case studies and how different companies apply ML in their workflows. And so if that's something that's interesting to you, you should um, definitely check it out. So I wanted to open up the floor for discussion. If anyone has any thoughts, comments, concerns, anything you generally found interesting, I'll go ahead and pause the recording.